is 1882 and the world's first hydroelectric power plant, the Vulcan Street plant, has just opened in Appleton, Wisconsin and is located on the Fox River. It uses the revolutionary technique of harnessing power of the sun and the water cycle in order to generate electricity for the 5 people in Wisconsin that can afford it.
Contrary to popular belief, people have been leveraging the power of flowing water for several millennia, thousands of years before the discovery of electricity. It started off in one of the first instances of society with the Mesopotamian irrigation system that used the flow of water to ensure well-irrigated crops. Several millennia later, the ancient Greeks and Romans began to capture the power of flowing water through the use of water wheels that were used to crush wheat into flour. The use of water wheels would continue through the Middle Ages and the Renaissance period, being used for automated hammering systems or cloth making or paper rolling. A lot of medieval life was powered through the use of running water in rivers, a bit like how we are so dependent on electricity nowadays. Nonetheless, it should come as no surprise then that when electricity was invented, that people like Thomas Edison and Nikola Tesla started to use the power of water in order to illuminate entire cities. The main concept for a generator is pretty simple. An electrical generator works on the same principle as an electrical motor, just in reverse. A turbine is connected to the magnetic rotor of the motor, and the rotor rotates inside the stator, which generates electrical current. Electroboom has a good video explaining this concept in his video about AC motors, which I will link below. Thus, hydroelectric power stations utilize the stored gravitational potential energy of the water in dams in order to convert it into electrical energy.
An advantage of hydroelectric power plants is that they're clean and renewable. This means that they don't put pollutants into the atmosphere, as is the case with fossil fuel power plants. It's also a great deal more efficient than those methods as well, as hydroelectric power is typically 90% efficient in comparison to the about 20% efficiency of typical fossil fuel power plants. Another advantage is that hydroelectric power plants can act as a sort of reserve or store of electrical energy. This can be used to normalize the electrical grid in times where the supply of electrical energy doesn't quite meet the demand. Tom Scott has a great video explaining this concept, which I will link in the video's description. This is in fact hydroelectric power plants aren't just sunshine rainbows and markets. This is due to the existing geographical constraints that women Hydroelectric power plants aren't all just sunshine, rainbows, and white ponies, however. This is in part due to the very specific geographical constraints that govern where a hydroelectric dam can and can't be built. For example, the hydroelectric dam has to be built in an area of high precipitation, which means a lot of rainfall. This is to carry the water from back downstream, back upstream, so power can be generated again. However, this itself is quite susceptible to fluctuations throughout the years. For example, take in 2015 in the Surikit Dam, which as a result of the droughts occurring in Thailand at the time, fell to about 20% of its operating capacity, which meant that its electrical generating capabilities were quite hindered. Another disadvantage of hydroelectric power is that it has quite severe impacts on the local marine wildlife and ecosystems. The construction and operation of hydroelectric dams can impede the passage upstream and downstream of migratory fish like salmon, which means that alternative pathways have to be put in place, which just adds to the overall operating cost.
A newer way of generating electricity through the use of water is with tidal energy. Turbines and paddles located in areas with a high tidal range use to shift in water levels due to the tide in order to generate electricity. The thing is, tidal power is relatively new, and there are only a handful of tidal power stations producing a commercially viable amount of electricity. This is in part due to the geographic restrictions, as there are only a few areas where there is a high enough tidal range to create enough power to be economically viable. And that's not even taking into account the even more severe environmental impact. Marine wildlife is greatly affected by the noise pollution and is often scared away by the turbines, which causes a domino-like effect on the food chain in that particular region.
In conclusion then, I believe that hydroelectricity will be here to stay for a while. It is a source of reliable, clean, and renewable energy that many countries around the world have taken advantage of, even with the severe geographical restrictions that a hydroelectric power station entails. Yet, it could be these same geographical restrictions that is the downfall of hydroelectric power, as many of the locations suitable for such a power plant have already been used. Thus, I consider hydroelectric and tidal power may be sufficient for the time being, until physicists can crack the code of nuclear fusion in the future to bring us clean and cheap, reliable energy.